Hi guys, this is in the series of the MPLS VPN videos that we've been taking a look at. This particular video that we're taking a look at over here it's an extension of the MPLS VPN video that we've done in the past, in which we took a look at how to do a VPN, an MPLS VPN for a client, a customer, within the same autonomous system. In which, if you take a look at this topology over here, what we did was, let me draw this out. What we did was we connected these PE routers, provider edge routers, to three different sites belonging to the same customer. So this would be, let's say, CE3, CE2, and this would be your CE1. Three sites belonging to the same customer. We connected it using an intra-AS MPLS VPN. One of the main objectives of that particular video was, from a design perspective, trying to keep the control plane traffic segregated from the data plane traffic. So what I've done over here, I've set this as a route reflector for MPI-BGP, and these would be three MPBGP clients that are all exchanging routes with each other through the route reflector. These links that you see over here, let me clear this out. The links that you see over here are your links. Okay. These are links that will be used to propagate your control plane traffic, basically your MPI-BGP neighbor relationships. When router 1, which is getting a route, or router 3, which is getting a route from the customer edge over here, takes a route, sends it, or propagates it to the route reflector over here. Route reflector will propagate the route to 1 and 2. But the thing about IBGP, especially with a route reflection, is it does not change the next hop. So when R1 or R2, which are other 2P routers, receive the route, their next hop will still remain as R3. So they're not going to use this link that is connecting R1, R2, and R3 to the route reflector to communicate to each other. They will use this link to communicate. Now, the good part about that is, when you're doing a design consideration, you have the ability to dedicate more resources for something like this device, which is along the lines of memory, because it needs to have a bigger routing table or a BGP table. But in terms of the resources on the interfaces themselves, this can be a 1 gig interface, because there's no data that is actually traveling between R1, R2, R3 towards R5. It's just control plane traffic, which is routing updates. But along the same lines, if you really take a look at it from here, from the perspective of your data plane traffic, which is going to use this fast speed link, I can put 10G or 40G over here. So the communication for data plane between the three provider edge routers will use a fast link, whereas the control plane can be segregated on a single link plane. Once we're done with that, our objective over here, the main objective of this lab, this we have done in the previous MPLS VPN setup, but we need to do it again to set that up. My objective now is to take it one step further and connect the two different autonomous systems where this client, this particular customer of yours, has some customers that are connected to this service provider, and some customers that are connected, sorry, wrong place. Some customers connected to PE routers on this service provider, but some others are connected to another autonomous system, another service provider. Why would that happen? Maybe the first service provider does not have POPs, point of presence locations, for the different customer sites that this customer has in other locations. But in the same realm, what you also have over here is the two service providers have an agreement where they can specify or connect up to each other so that they can exchange the routes from one side to the other. But before we get into the inter-AS MPLS VPN option, let's go ahead and take a look at and set up our normal intra-AS MPLS VPN. My objective over here is going to be to connect 3 sites which are connected towards three sites of the same customer There's a R11 over here, R12 over here, R13 over here. I want to set up R1, R2, R3 as provider edges that are connecting towards 11, 12, and 13. These are my customer edge routers. These 3 customer edge routers belong to the same customer. The state of my network right now is very basic. What I've done on my network right now, and let me connect up all my devices to each other, is basically going to be, what I've done so far is really my IGP and my LDP. That's all I've actually taken care of right now. So let's go ahead and launch my devices. Yeah, LDP and OSPF is up. Other than that, nothing else is up. So the first thing that I'll do is I'll set up my MPI BGP neighbor relationships between my different devices. Total, I have 16 routers. Whatever I'm going to do on AS100, I'm going to repeat the same thing for AS200. So I'll have 2 different ISPs having the different customer routes. All right. So with that in mind, actually I missed one. So I have all 16 of my routers up. So the first thing is to do this. My physical connectivity is there. My MPLS is there, unicast routing. My LDP is running. My OSPF is my IGP that's running within the autonomous system. 1, 2, 3, 4, all 4 devices are actually communicating to each other right now. That's the state of my network at this particular moment. So my objective is, once I set this up, R1, R2, R3 to communicate to R5 for the route reflection and have a complete intra-AS MPLS VPN setup, then the next objective would be to configure the same thing on 6, 7, and 8. If I had to draw it out over here, let me just do that as well. Bring this down. I'll set up 3 different customer edge sites. This is your customer edge sites. That would be 11, 12, and 13. These are 3 customer sites that are connecting to its appropriate PE router. Good. My connection is right over here. So I'm going to run some type of routing protocol. In our case, we'll just run BGP as my PEC protocol to make it simple. I don't need to do redistribution then. So the first things, but before we get into the customer side of things, let's set up our IBGPs on your R1, R2, R3, the PE routers towards R5 being the route reflector. Let's go ahead and do that. So I'm going to go to router 1. And by the way, just to show you the topology, this is the actual physical topology over here. If I had to draw it out, oops. This is the physical setup, the one that I just showed you, of connecting these different devices to each other. This is one AS and this is the other AS. All right. With that in mind, let's go ahead and set up the neighbor relationships, IBGP neighbor relationships, MPI BGP between R1, R2, R3 towards R5. These are logical relationships over here. So I'm going to go to router 5. router BGP 100, neighbor 1.1.1.1, remote AS 100, update source loopback 0, 2222, remote AS 100, update source loopback 0, 3333, update source loopback 0. Once this is done, address family, VPN v4, neighbor 1111, activate, send community extended, and route reflector. Similarly, 2222, activate route reflector client, and send community extended. And my third one, 3333, activate, send community extended. Again, this is basically setting my topology up so I can do the inter-AS part. Let's do the stuff within the AS first. So I got my route reflector set up. This is my route reflector over here. Router 1 is my first client. Router BGP. Actually, I can do this in Notepad because it's going to actually affect all three devices. One sec over here. Router BGP 100, neighbor 5555, remote AS is 100, neighbor 5555, update source is loopback 0, address family, VPN v4, neighbor 5555, activate, neighbor 5555, route reflector client. No, sorry, I don't need to do that over here. Send community extended. That's pretty much it on R1, one of the PE routers. R2, same thing, because again, the reason I did it in Notepad or my text editor is so that I could just copy paste it onto all three, and because all three are pointing towards the route reflector. Let's make sure my neighbor relationships are coming up. On R5, all three are up. Now that part is done. Let's go ahead and do the PE to CE protocol setup. I'll create a VRF, and again, I'm going to use the Notepad over here. Change the font so you can see it better. The VRF definition. Call it cost A, RD 100:1, address family, IPv4, route target, both 100:1. Let's go to the interfaces. Let's check what the interfaces were. The interface between R1 and R11 was E02. I think the same thing, R2 to R12 is E02, and R3 is also E02. So on my side, on the provider edge side, it is interface E0/2, VRF forwarding, cust A, IP address, we'll say 192.1. Say 10.1, 255.255.255.0. Now let's go do 11 over here. Just keep it simple. 11, no shut, router BGP 100, address family, IPv4, VRF, cost A, neighbor 192.1.111, remote AS, we'll keep it as 650.11, and we should be done with that. Create the VRF. We'll go start by doing it on R1, and then we'll do it on R2 and R3 similarly. So that took care of one of the PE routers. Now I'm going to do the same thing on router 2, which is towards 12. This stuff remains the same. The interface remains the same. The IP address, I'm going to change it to 12.2. And on the other side, I'm going to say 12.12 as my remote AS, and I'll keep the thing as this guy, and my side is the same. R2 should be done if I do this properly. All right, now R3. Again, I'm going to change this. 13.3, 13.13. Copy. Done. So my PE side is done. Let's go ahead and do the corresponding CE side. Again, my best friend, the text editor. This is R11. En config T. Do no IP. Domain dash lookup. Host R11. Interface E0/0. IP address 192.1.11.11. Interface loopback 0. IP address 10.11.11.0 or 11.255.255.255.0. Router BGP 650.11. Neighbor 192.1.11.1. Remote AS is 100. My network statement 10.11.11.0. Mask /24. So this should take care of one of my customer edge routers. That is R11. Now while it's doing its thing, we'll do R12. 12.12. Loopback is going to be all 12s. This is going to be 12.2, I believe. And this is going to be 12.12. In the meanwhile, this is R12. Meanwhile, the first neighbor relationship has come up. This is R12. That's it. Let it do its thing. We'll change 13 now. 13.13. The AS is wrong on the other one. We need to make it 12. That's okay. We'll fix this first. We'll finish R13 up first. All right, 12 needs to be reset. No router BGP 11. All right, router BGP 650.0.0.12. Neighbor 12.2. Remote AS is 100. Network statement was 412. There you go, the neighbor's up. Now, if everything's fine, This one received it too. Let's check over here, show run, section router BGP. What do we do wrong? Okay, this one is wrong over here. So router BGP 100, address family IPv4 VRF cust A. Neighbor, no neighbor, we'll get rid of it first. And the global, I have to have it. Yep, 12. No neighbor, 192.1.13.3. Mode AS 65012. 1.13.3, remote AS is 65013. Address family, VPN v4. Neighbor. This has to be 13.13, the other guy. All right, neighbor. Oh no, not over here. Address family, IPv4, VRF, cust A. No neighbor. 13.3. What I have right now, I just need. I need to get rid of this. There you go, should be okay now. Check this, this is up. Try to route BGP, 10.12 and 10.13 are there, so this should have come up by now. There you go. So right now, if I sit over here, I can do a trace to 10.12.12.12. Can I ping it? Oh, wrong address. No, it's right. Show IP route, BGP. This one has it. Let's go to R3. Show IP route, BGP, VRF, cust A. It's got it. Show IP, BGP, VPN, v4 all. This one has it. Show MPLS MVP neighbors. It's got a bunch of different neighbors. Trace route to 1.1.1.1. It's direct because it's going to be going direct over there. So let's try it now. Okay, 10.13. So if I go to 11. Okay. Should be going. Show IP route to go to 1, 2. It's going through Ethernet 0, which is direct. 10.2. I'm going to make sure that their labels are there. That's what I'm checking right now. BGP, VPN, v4, VRF, cust A 10.11.11.0. There's the MPLS label. Should be able to go across. This looks good. Oh, use the source because I'm not, that's it worked. I was not using the source, so I was using the physical address. I have not advertised that physical address. So if I do a source of this guy, it should be working fine. I have not advertised a physical link between the PEC, just advertise a loopback, so that's getting propagated. So I have 1, 2, 3. So if you go back into the diagram over here for BGP, these guys now can talk to each other through this R5 being the route reflector. But physically, the data, that's what I want you guys to be very aware of, is the segregation. Although my routes were propagated via this guy. So R1 was communicating to CE1, and it wants to go to CE3. Although the route propagation went like this, R1, when it sends the route towards R3 via R5, it does not change the next hop because this is a normal route reflector. So when he gets the route, the next hop is still 1. And based on its IGP, it knows the best path, the direct path from 3 to 1 is using this fast link. So the data path is going to take the fastest link where the propagation is done through the central router, the control plane router, the BGP router. And I'm going to do the same thing on the second side as well. I'm going to set this as the RR. It's going to have relationships with the different PE routers. Let's draw that out over here for you guys so you guys are aware of it. We'll go to the other diagram that we have, this guy over here, and we'll replicate this. Okay. This guy over here, I'm going to copy it, paste it. I'm going to change the numbers, but this can remain the same. Okay. R14. R15. R16. So I'm going to do the same thing over here. So 14, 15, 16 should be able to communicate to each other. 11, 12, 13 should be able to communicate to each other. But again, the main purpose is to set up EBGP, and that's where I'm going to give you the detailed steps for that. But before we do that, let's go ahead and do R6, 14, 15, 16. All right? So let's take a look. Again, let's do this over here. R11, this becomes 14. And router 14 is connected towards, let's say 1, 2, 3, 4, 5, it would be on 6. So we'll do 14. 14.14. Now my side is 14.6. The other side will be 14. Whatever. Oh no, sorry. I am 14.14. My AS number is 14. My relationship is to 14.6. Advertise 14 and be done with it. This is on 14. Similarly, I have 15. So I'll go over here. 15.15. My AS number is 15. This should be 15.7. This is 15. And that should set up my router 15. Now the CE router is done. The last CE router over here. (16.16). 16.8. So my CE routers are done. Now let's work our way in the service provider cloud. Again, on the service provider cloud, if you really look at it, I need to set up a relationship in this AS. My second AS, my route reflector is 10. So 6, 7, and 8 are going to set up a IBGP neighbor relationship towards 10. And I want to find out what is the loopback of 10 before we configure this. Let's do 10 first, actually. That is the route reflector, show IP interface brief. I put it as 100, 100, 100, 100. Router BGP 200. Neighbor, we have 6. Remote AS is 200. Update source is loopback 0. Neighbor is 7. Sorry. This is 8. And update sources, again, loopback 0. Once this is done, I'm going to set up my address family VPN v4. Again, 6. Activate. Send community extended. And my route reflector client. Neighbor 7777. Activate. Send community extended. And route reflector client. Eight. I've done that already. Send community extended. Route reflector client. That's my route reflector done. And the route reflector IP address that I'm going to use for the neighbor relationship is 100, 100, 100, 100. So all the other ones, basically I'm going to do this, 100, 200, sorry. The neighbor is 100.100.100.100. All right, that should set up my IBGP neighbor relationship, and I need to do this on all my devices that are my PE routers in AS200, which is basically 6, 7, pointing towards the route reflector, 8. Let's check. Try BGP, IPBGP summary. Idle. Show IP route. 6 is there. Okay. Should be active though. 6, 7, and 8. I know how to get to 6, so let's go check over here. And what am I missing? This is what I'm missing. Okay. This stuff is simple. Now let's check. There you go. The neighbors are up. So if that's the case, let's see what the next thing is to do the VRFs. This one we'll say is same customer, but different route target because and route distinguisher, different AS. This is also, I believe, E02. Not this one. E02, E02 and E02, yep. The interface is towards the customers. And this is going to be 14.6, the first one. Customer A, this is BGP 200. 14.14. This is 14. So let's go to 6. Let's see if it comes up, and then we'll do the other ones. What does 14 have? Same stuff over here. The thing is, it's right over here. No, router BGP 650. Router BGP this. And this will be 14.6. Remote AS is 200. Should come up. While it's doing that, change this from 15. And this is going to be 15.7, and this is going to be 15. Should have it. So we have the right number as well. And as you guys can see, the neighbor has come up. So if you go to 6, I should have 1014 in my BGP table, MP BGP table. 17 is neighbor up, show IP, BGP, VPN, V4, all. Not yet, 17. 7 is connected to 5. Okay. Okay, I haven't done this guy yet. So let's do that. VRF definition, this is good, this is good. This would be 15.7. The local side, the remote side is going to be 15.15, and this is 15. There you go. Send the local. Hit the neighbors up, and eventually it should come up over here as well. There you go, 14 and 15 are done. Let's check 16 now. Yeah, this one needs to be fixed again. Same thing, 16, 16. This is going to be neighbor 16.8, 16 and 16. So my customer side is done, and now I need to fix my service provider side. Now the fun starts. This is 8, 16, 16 and 16, and this is 16. This would be on 8 towards it. Let it come up. Neighbor up, and the route's there. Do ping 10.14.14.14, source loopback 0. Do a trace. Working like a champion, and less number of hops. So essentially right now, if you take a look at this diagram over here, my setup is complete between my different devices over here within the same autonomous system. So these guys now have full reachability to each other. And these guys over here, we'll use a different color, have reachability to each other. Now my objective is to connect 11, 12, 13, which belong to the same customer, but they're on two different service providers. The two service providers have a relationship which allows them to have customers that have sites across the two service providers to talk to each other. Now, again, I'm going to do the same thing over here. I'm going to set up an MP eBGP neighbor relationship because these two guys have all the routes. I want to set them as neighbors with each other so that they can exchange the routes for 1, 2, and 3 all the way across over here. So my MPBGP is only between the two route reflectors. But at the same time, what I also want to do over here is I don't want traffic, all the traffic to go through this. This is the BGP diagram that you have. If you look at it from the perspective of your physical path, yes, I am going to set up a neighbor relationship between these two guys over here, although the physical path has to go through the autonomous system boundary router, the ASBR. In our case, the ASBRs are these two guys here. Now, although I'm going to use this physical path to set up the neighbor relationship, or right here, there's a link. Once the neighbor is established between the two routers, I'm going to set up MP eBGP in such a way that all the routes that he gets, because it's eBGP, it would have pointed the next hop to R5. I don't want to change the next hop. So when he gets all the routes, the next hops for example, for 10.11 should still be maintained as R1. 10.12 should still be maintained as R2. So I'm going to do a next hop unchanged over here. By doing that, I am going to allow these guys, when the route reflector reflects the routes towards its IBGP neighbors, it's going to reflect the route telling, hey, listen, if you want to get to 10.11.11.0, what I want to do is I want you to send the traffic to R1. So that way, when the packet comes in, the data traffic comes in, it's going to go from R8 using this link to the ASBR to R4, but it's going to look for R1. It's not going to go through the route reflector. It's going to go directly to R1. So the PEs are going to talk to each other directly. But for this configuration to work properly, what needs to happen is that your labels have to be exchanged for the next hops. So R1, R2, and R3 need to get propagated all the way across to the other side so that they can have reachability to R1, R2, and R3. So that's a drawback of this particular design, that you need to leak out the reachabilities to your PE routers to the other side. If you have 10 PE routers, all the 10 routes need to be propagated to the other side because their next hops are going to point to the PE routers. The good part about that is now you have direct communication between the PE to PE rather than having to go through the route reflector. The other option would be have all the traffic come into the route reflector. In that case, the only address that you need to leak out would be for this particular one, which is R5. Does that make sense? So something that you need to keep in mind when you're doing this, okay? The first thing that I'm going to do over here is I'm going to set up a normal MP eBGP neighbor relationship, or actually normal relationship, eBGP neighbor relationship between the ASBRs, which in our case over here is your R4 and R9. Normal eBGP neighbor relationship between the two devices. Once I'm done with that, then I'll go ahead and set up my relationship. I'm going to leak out all my next hops so that I have reachability of the next hops in the other domains, and set up my eBGP neighbor relationship, MP eBGP neighbor relationship between the RRs. Okay, let's take a look at the steps. The first steps, I'll write them down for you so you have them and understand what are the different things that you need to do over here. So the step one in setting this up, leak the next hop for the PE and RR routers into BGP on the ASBR, which is R4 and R9. All right. Do this by doing a controlled redistribution of OSPF into BGP. I'm going to do this on R4 and R9. What I'm going to do is I'm going to create an ACL, access-list1, permit host 1111. Two, 3333, and 5555. All right. Once these routes are put in the ACL, I'm going to create a route map, ABC, or I'll say OSPF to BGP, match IP address 1. I want to redistribute these routes into BGP, router BGP 100, neighbor 192.1.34.4, remote AS, is it 34.4? No, 49.9, because 429, 49.9, remote AS is 200. All right, neighbor 192.1.49.9. I'll say a command called send label so that I can exchange any routes that I send into BGP. I'm going to send a label with it as well, an MPLS label for it as well, for the propagation of these routes into the other domain. And what routes? Redistribute OSPF 1 route dash map O to B. Good. This is on R4. So what this does is it will exchange the routes between, because I already have these routes to my IGP 1, 2, 3, 4, 5. I'm going to exchange 1, 2, 3, and 5. I don't care about 4. 1, 2, 3, 5 with the other guy. Did I put that in the, yeah, with the right ones. Paste it. Okay. Similarly, on the other side, I'm going to leak out 6, 7, 8, and 10 is 100. That's your route reflector. My AS is 200, 49.4 is the other ASBR, and this guy over here is 100. Send label, same thing, OSPF to BGP. That is on R9. Again, it should have all these routes. 6, 7, 8, and 100. All right. So let's take a look. Show IP BGP. Give it some time. Show run. Oh, there was one. Show run router. O2B. Just making sure everything is in place. There you go. Now on the 2 ASBRs, I have all of those 8 routes. 1, 2, 3, 4, 5, 6, 7, 8, and 100. 100 and where's 5? 1, 2, 3, 4. 1, 2, 3, 4. These routes are available to me in my BGP table. All right. But at the same time, I need to actually propagate these routes into OSPF as well, because if you really look at it, this guy still hasn't received it. Yeah, my autonomous system has it, but I don't have it. So what I've done at this point is just gotten the routes to my edge. There's my BGP one. So the routes now have been exchanged using the ASBR between my R5, actually not R5, that's not this diagram. It's this guy, it is R4 and R9. So I have the routes over here, and R4 and R9, I still need to send them into my OSPF domain. So R1, R2, R3, and 6, 7, and 8 get the routes from the other domain. So now I'm going to do another route map that will redistribute into here 6, 7, 8, and 100. And into this guy, I'm going to redistribute 1, 2, 3, and 5. Because I have it on the ASBR, the edge router, but I have not propagated these routes into your IGP, and that's my next objective over here. So let's take a look at how to do that. Again, very similar to what you did. The only thing is I'm doing it in reverse now. So once this is done, the next step, so this would be step 1. Redistribute the next hops from the peer AS into the IGP. In our case, it's OSPF. So again, I'm going to create a ACL. I'm going to create this ACL on 1 because it's going to have these routes, but I have ACL 1 already, so I'll call it ACL 2. Route dash map. This is going to be from B to O. match IP address to router OSPF 1, redistribute BGP 100, subnets, route-map, V2. So now I'm getting all the routes from one edge to the other. Copy. Let's do this on R4. And by doing this, R1 now should have 6, 7, 8, and 100. There you go, 6, 7, 8, and 100. These are the 4 external routes. And I need to reverse it on the other side. How do I reverse it on the other side? On this guy, it's going to be 1, 2, 3, and 5. Match the ACL, this is the same. I just need to do a difference of the autonomous system and I should be good to go. And this should be done on the other ASBR, which in our case is 9. Now, all the PE routers have reachability to the other PE routers, and you can verify that to a trace route to 1.1.1.1 from source of 8888, for example. All right. Or if I go to 10, which is my RR, I should have reachability towards my other RR, which is 5. Good. Now, the simple part. Let's set up an eBGP neighbor relationship between your 2 route reflectors, which is 5. Over here, I'm going to set up a route reflection. eBGP neighbor relationship towards 200. So neighbor is 100.100.100.100. Remote AS is 200. Update source is loopback 0. Because it's multi-hop eBGP, I'm going to say BGP eBGP multi-hop. There you go. That's taken care of. Address family, VPN v4, same neighbor. Activate, send community extended, and I won't do that right now. I'll just leave it off. I want you to see what happens if I don't. That's the next hop unchanged. I'll go to the other guy over here. Router BGP 200, neighbor 5555, remote AS is 100, update sources loopback 0, eBGP multi-hop, address family, VPN v4, neighbor 5555, activate, and send community extended. Show IP BGP, VPN v4, all. There you go. I got all the routes, but the next hops over here are what? The RRs. So this will be suboptimal forwarding. All traffic will come through the RR. And if I go over here and I do the same command, it's all pointing towards 100, which is not a good sign. The reason it's not a good sign is all my traffic now will get forwarded through the route reflector, and you want to avoid it. You want to go through directly from the ASBR directly to the PE routers. And the way you do that is you go to your route reflector in your neighbor statement. You specify your next hop unchanged. It's an eBGP neighbor relationship. Normally it changes the next hop. You want to unchange it. So we'll do the same thing on 10. Router BGP 200. Address family, VPN v4, neighbor 5.5.5.5, next hop unchanged. To clear IP BGP star soft, check it now. All right, so you take a look. It's going what? It's got the next hop of 1, 2, 3, and that's the first thing that I did was leak out these next hops, so now I have reachability. Now if I go to R11, one of my customer edge routers, show IP route, and I'll make it more concise for BGP. Give it some time. Should propagate that across. Let's check. Why is this not getting it? And okay, wrong place. Show IP route VRF. Oh yeah. Now I'm not getting this over here. The reason for that is if you remember the VRF definition that we had on this side, on all the 3 routers, it was only importing what? The 100:1. So over here, I need to do a VRF definition. Cust A. This is on this side. Address family, IPv4, route target, import. I want to import 200:1 now because I was importing 100:1 only. I'll go to router 1, import router 2, and router 3. That way, if I do show IP, BGP, VPN, V4, all, should now see all routes, 10, 11, 12, 13, 14, 15, 16. So should this. And should this. This one should also have it. Good. Now, if I go to the other side over here, 11, I should see a bunch of different routes. Again, I need to repeat that, otherwise 14, 15, 16 won't have the routes. Right? You don't have 11, 12, 13. Again, the reason for that is on this side, I need to import 100:1. So if I go down over here towards 6, 7, and 8, show IP, BGP, VPN, V4, all, nothing. Import. There you go. Import everything. 8, same thing. Brilliant. So this is done. What's the next thing? Bing. Let's check. Do 16 have the other routes? Should have all the routes now. Show IP route. Just do BGP. 11, 12, 13, 14, 15, 16 is myself. Ping 10, 11, 11, 11. Source loopback 0. There you go. Trace route. 10, 11, 11, 11. Source is loopback 0. There you go. And if you look at the path, because of the way I've set this up with the unchanged and all, my data path is, let's say I'm going from 16 to 11. I'm going towards this guy. He's going to have a next hop of 1.1.1.1 based on the redistribution of the next hops on the ASBR. He will know that he needs to go directly to 1111. The path it takes, it will depend on the physical path. So if you go over here and you take a look at this thing, or actually let me show you the other one, and trace this one. You look at this thing over here. When 16, which is connected, actually connected to 16 is connected to 8. When this guy pings over here, he's going to go to 8. His next stop over here is going to be 1. Goes directly to R9. R9 forwards it to R4, which is the ASBR. ASBR will go directly to R1, although the route propagation did not happen like that. The route propagation had happened from where? R1 has sent the route to R5. R5 using this link had gone to R4, 4 to 9, and 9 had sent the path directly to 10. So the data path and my control path are completely different. And that's exactly what you want to do, so that you can have or concentrate on having more memory on this side and more speed on this side. This option is known as Inter-AS MPLS VPN, option C, in which the neighbor relationship is done based on the route reflector to the other route reflector in the other domain. Option C. And I've done the topology in such a way that it's optimized for forwarding of traffic. All right? Good. Hope you enjoyed the video and keep subscribed to the channel, and I'll be posting other videos over here. Thank you. Take care.